Hello! In this video we'll be talking about translating conditional statements and loops into assembly language. So in high-level languages like C, they're conditional statements of the form if or if-else, and they're loops of the form while or for. So we'll look at how to translate each of these. So suppose we had an if statement in C. If I equaled to j, then f equals g plus h. And in any case, f equals f minus I. And let's say our variables were stored in registers like this. S0 has f, S1 has g, S2 has h, S3 has I, and S4 has j. And the first thing we would need to do is compare if I equals j. If I equals j, we want to do the body, but let's figure out when we want to skip the body. That's the opposite condition, so if I is not equal to j, we want to skip the body. So we'll start with a branch on not equal. S3 has I, S4 has j, and let's go to some place, we'll call it label 1, to skip over. Make a better question mark there. J question mark. Now, if they are equal, we want to do the body. So that would be add f is in S0, gets S1 plus S2. Now we'll have label 2, and this is where we would continue with the f equals f minus I. Subtract S0 gets S0 minus S3. So when we have an if statement, we check if the condition is false. If it is, we branch to something after the if statement. Then we do the body of the if, and then we continue with the code for after the if. Suppose we had an if-else statement, similar, but now the f equals f minus I should only be done when I is not equal to j. So we'll start out again, branch on not equal, S3, S4, label 1. Let's call this label 1 this time else. If they are equal, we do the body, add f is in S0, S1, and S2. F equals g plus h. But now we don't want to do the else when we were in the if, so we need to jump to some label done. Now at the else label, we do the f equals f minus I, subtract S0 gets S0 minus S3. And then we have our done label, where the code resumes in either case. Let's take a look at loops. Suppose we wanted to write a little program that computed what power of x satisfies 2 to the x equals 128. And we were going to do this by starting with 2 to the 0, and then just keep counting powers until we get there. So here we'll start x is 0 and 2 to the 0 is 1. Then we'll see as long as the power is not yet 128, we will double the power and we'll add 1 to x. So first power is 1, then power will be 2, then 4, 8, 16, 32, 64, and finally 128. And at that point x will be 7, so we'll discover 2 to the 7th is 128. So first we need to assign our inputs. We do that with the add I. So pow is in S0, and we can do add I. S0 gets 0 plus 1. That does pow equals 0. Next we need x to be 0, so that could be another add I. S1 gets 0 plus 0. X equals 0. Now we'll have the while loop. we need to compare POW to 128, so we needed to have the number 128 sitting someplace we can use it. And so let's actually load that into a register as well. How about we put it into a temporary register, maybe T0. Now, we want to continue doing the body of the while loop as long as POW is not equal to 128. So the opposite of that condition is POW equal to 128. We'll do a branch if equal, POW is in S0, and T0 has 128. So we'll check if it's done, and if so, let's go to some label 1. That will be down here. Now we can do the body of the loop. So POW equals POW times 2. Multiplying by 2 we can do with a left shift in assembly language. So logical shift left, immediate. POW is in S0, S0, 1. All right. And then add 1 to X. Add S1 gets S1 plus 1. And then we're done with this loop, so we need to go back and check the condition. So we want to unconditionally jump back to the while loop. So again, the idiom is we set up our variables before the while loop. In the while loop, we compare. If the condition is not satisfied, then we'll branch to a done. Then we do the body of the loop, and then we jump back to check the condition again. For loops are similar. Remember, a for loop in C has 4 parts. It has an initialization that takes place before the loop begins. Then it checks the condition at the beginning of each iteration of the loop. If the condition is satisfied, we do the statement, and then we come back and do the loop operation, and then go back to the beginning of the loop to check the condition again. And as long as the condition is satisfied, we continue executing the statement in the loop operation. Otherwise, we leave the for loop. So let's say we wanted to write a little program to add up the numbers from 0 to 9. We'll have a variable for the running sum that will start at 0, and we'll have a variable I to count from 0 to 9. Our for loop has an initialization to set I to 0. Its condition is I is not equal to 10. So as long as I is not equal to 10, we'll continue doing the body. In the body, we do sum equals sum plus I to add the current number. And then in the loop operation, we do I equals I plus 1. So after each iteration, we add 1 to I, and then go back and check our condition again. So starting this out, sum equals 0. Well, sum, let's keep it in S1. So we'll add I S1 gets 0 plus 0. Now we have the initialization of the loop, I equals 0. Add I S0 gets 0 plus 0 for I equals 0. Now we need to check the loop condition. We'll have a label here at the start of the for loop because this is where we'll return on each iteration. So if I is not equal to 10, we want to leave the loop. So we'll do a branch equal if I is equal to some temporary register containing 10, then we'll go to done. And let's put temporary 0 holding the number 10. So if I is equal to 10, we leave the loop. Otherwise, we do the body. Sum equals sum plus I is add S1 gets S1 plus S0. And then we do the post operation, I equals I plus 1. That would be an add I. plus 1. And finally, we're ready to jump back to the for label to check the condition again. And here we'd put a done label to continue when we're done with the for loop. Here's another example of a for loop. Let's say we wanted to add the powers of 2 from 1 to 100. And this time, let's use a less than comparison instead of a not equal, just for variety. So again, we'll initialize sum to 0 as an S1. At I, S1 gets 0 plus 0. And we'll start I at 1. And we're going to need to be comparing against 101, so let's put that in a temporary. Now we have our for loop, and we start by checking the condition. So if I is less than 101, we want to do the body, so the opposite condition is greater than or equal to. So we'll do a branch on greater than or equal to, comparing I to 101. If it's less than, we'll do the body. If it's greater than, we want to go to a done. Now we get to do the body. Body was sum equals sum plus I. S1 gets S1 plus S0. And now we do the post operation, loop operation. I equals I times 2. We can do that with a shift left. Shift left immediate. S0 gets S0 shifted left by 1. And then we need to jump back to the for loop to continue checking the condition until I is no longer less than 101. That was using the branch on less than or greater than or equal to. There's another instruction in RISC-V assembly that's handy to know. It's the set less than instruction, and it compares two numbers, and then it puts a bit into the result, the destination register. That's 0 if the first thing is not less than. It's 1 if this first thing is less than the second source. So here we could use a set less than and then a branch equal comparison. So we could set less than some temporary register T2. If I is less than 101, then we'll set T2 to be 1. Otherwise, we'll clear T2 to be 0. Then we can do a branch if T2 is equal to 0 to done. So this is not more efficient in this case because the set less than is one instruction, branch equal is another. We could have just done a branch on greater than or equal to like we did before. But sometimes if you need to put a Boolean based on relative comparison into a register, set less than is handy for that.